This is going to be my informative speech. It's the age-old story. When a student walks into their final class of the semester with their dissertation on the flash drive, walks up to the teacher, gives it to her, and a couple hours later when the teacher tries to use it, it doesn't work. She emails the student. It turns out that that was the only copy, that was the only backup. Hundreds of hours gone. Why? Because she didn't back it up. So what's the solution to this? Anybody can say back up your data. Wake Forest tells us this. But what specifically do we need to do, and what solutions can we look at that are viable and modern enough, while also being inexpensive? I'm here to inform you on modern solutions to data storage problems, and I'm also here to talk about the two types of data storage. You've got physical and cloud computing, and how they both have a different set of pros and cons that are situational to what you're doing. So the first type is physical data storage. This is the kind of the traditional but more expensive type of data storage, because this is like the mercury tubes, this is the flash drives that you've seen your whole life, this is the stuff in the bottom of your computer. So there are three specific types of physical within the department itself. You've got your native hard drive. So think of your ThinkPad, right? If you turn it over and look at the bottom of the little outline, that's going to be your native hard drive. On a ThinkPad, you normally have 250 gigabytes, and that normally works out pretty well for us, provided you aren't downloading movies upon movies upon movies. It can be upgraded. It kind of is our first level defense against data loss. And it can be upgraded if you go on Newegg or Amazon. 1 terabyte is normally about $60, to give you an idea of how much 1 terabyte is. You can fit about a couple million pages of text and text and pictures into a terabyte of data. The next type of physical storage is transportable drives. So this is flash drives, this is external hard drives. A flash drive is a thumb device, normally about 32 gigabytes for $20 on Amazon. Generally, when it comes to data, the smaller it is, the more expensive it is, because you're kind of packing more things into a smaller thing. So the flash drive is great, because if I have to get one paper from one computer to another, and I know that I really want to have a physical form of that, you turn to the flash drive. If you need to turn to kind of bulk data processing, you go to an external hard drive, which is basically like a little computer of its own that runs as a subset of your engine. And you can normally get one of those for about a terabyte of data for about approximately $80, but that varies because the design of the external hard drive normally is kind of important to people. Finally, the last type of physical storage is a stationary data center. This is the physical form of cloud computing. Basically, all the data is processed by a company instead of your own computer. Basically, you get massive warehouses that are incredibly cool because the computers are generally hot, and you get rows upon rows upon rows of data storage towers. They're about 10, 11 feet tall, and all they are is just hard drives, hard drives, hard drives. And companies like Google and companies like Yahoo have to rely on this for as an internet database. Now, I said cloud computing. What is the cloud? We see this on a quite regular basis. Apple markets it pretty heavily. I feel like Google is starting to begin an entrance into cloud computing. And what it is, it's like a new expensive alternate to what the physical form has provided us. And I feel like cloud computing is best explained with an example. Let's say you're at a company, right? This company has a web of computers used for basic tasks. These are our web of computers. On every one of these computers, we're going to need a set of programs that are going to be useful in completing day-to-day work. But by putting every single program on every single computer, you're causing strain and a lot of work. So what happens instead is you get a mainframe where you run these programs from, and what happened is that the strain of processing and data storage, instead of being put on these computers, is put on a mainframe. The same principle applies to cloud computing. The strain of data storage is put on one big mainframe, aka the data center, whereas our computers act as the web of computers. So pricing-wise, it's a little difficult because it's still new technology and you should expect it to change. But if you go to Google Mail, for example, or Google Drive, you're going to get 5 gigabytes of free data a month. This is a lot of data, as I've previously stated. If that's not enough for you, you can go to Dropbox.com or something, and for $10 a month, you can get 100 gigabytes. That's even more data. That's more for the businessmen and people who really need to be crunching down. Now, the cloud computing has a very, very specific set of pros and cons because the pro and con share the same kind of base, but the thing is, cloud computing is incredibly reliant on connectivity. One of the biggest pros is that I can go to my class and be able to access a document, but at the same time, if I don't have that computer access, there's no way I can get my stuff. The reason that these two things are issues at all is because the importance of data has increased with the recent information age. Tech failures have very real-world consequences, and as a result, we need to work on minimizing these via storage backups. Options like your native hard drive, external devices, and cloud computing offer solutions to these very delicate problems. So next time you finish your paper, next time you take that congratulatory sip of water and save it for the last time, take an extra 10 minutes to back it up, because you'll never know if you're going to be able to never see it again. All you need to know are the options that are there.